Okay, if you missed the Zoom call on derivatives graph, Reteach, I hope you're watching this video and this can get you caught up. So if we look at the first problem, we are given the graph of f prime, the derivative graph. So the figure above shows the graph of f prime. And the domain is all such numbers from -10 to 10. So we're just going from -10 to 10. And now the first question asks us, for what values of x, so which x values, does a graph of f have a relative minimum? Now, some of us might be inclined to say this point right here is a relative minimum. That would be a relative minimum of f prime. So remember that this is f prime, and they're asking us about f, this original function that we can't see. So unfortunately, it's not so easy as just identifying the low points of f prime to find the relative minimum of f. But what is nice is that we can go up to our reference sheet and we can figure out, how do I know when f has a relative minimum? So let's go back up to our reference sheet and see, how do I know when f has a relative minimum? So if I look, we can see that f has a relative minimum when f prime, which is going to be our graph, has a derivative of 0 and changes from negative to positive, or on the x-axis, and it goes from below the x-axis to above. So we're looking for a point that's on the x-axis, but it goes from below to above at that point. That would tell us that we have a minimum on our original graph that we can't see. So let's just go back and see if we can find that on this graph. All right, so we're looking for, once again, two things. We're looking for where it crosses the x-axis. So I see points here, 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 and here. So it has to cross f prime, and it has to go from below, negative, to above. So I see negative to positive here. I see positive to negative here. I see negative to positive here, and from positive to negative here. So the only points that it both crosses the x-axis, has a derivative of 0, and goes from negative to positive would actually be -7 and 4. So if I were to actually write out a complete sentence for this, it might look like this. So I want to start my sentence frame with the following. I want to say f has blank at blank because f prime blank. All right, so this is just a general sentence frame to help us kind of put some meaning to this math. So let's first talk about what f is doing here. F has a, what are we looking for? A relative minimum at, well, where did we find those relative minimums? I believe they're at -7 and 4. So x equals -7 and x equals 4 because, and now we're going to justify this by saying what f prime told us. So we know that because f prime is equal to 0, you could also put on the x-axis, that would be a synonym, it's equal to 0, and what else? F prime changed from negative to positive at those values. Okay, so this would be kind of like our perfect little AP full credit response in a situation like this. I'll highlight that in green. Green is a bad choice. How about dark purple? Okay. So why this makes sense again is if we think about f prime is just telling us the slope. So if we have a negative slope, we're going to go from decreasing to increasing, and that kind of spells out that we have a minimum there. And remember that minimums will always have a horizontal asymptote there. So that's why we have a derivative of 0. So it looks like this on f, but when we go to f prime, we're just graphing the derivatives. So the derivative is 0, and it's going from negative to positive. Derivative is 0, and it's going from negative to positive. All right, so that's the reasoning, and that's our explanation and our justification when given a graph. All right, so we'll do one more. So we'll clear this, and let's look at the next question. For what values of x in the interval from -10 to 10, so the same interval, is f concave up? So once again, we're looking for when f is concave up, but remember this is f prime. So let's go back to our reference sheet and let's look for f concave up and see what f prime tells us when f is concave up. All right, so we go to our reference sheet, we see f is concave up right here. What does that tell us about f prime? Well, that means that the derivative is going to be increasing. So the slope is going to be increasing. The slope is going to be going up. All right, so our slope is changing, and not only is it changing, but we're kind of increasing at an increasing rate. So in order to find when f, our original, is concave up, all we have to do is find when our f prime, our derivative, is going up, is increasing. So we're just looking for increasing parts of f prime to notice concavity in f. So let's go back and find increasing parts of our graph. All right, so let's see, where is our graph increasing? Well, if we start from the left, it's definitely increasing from here all the way to here. It looks like about -3. And then it starts to decrease, so it must be concave down until -2. And then from 2 to 6, it increases again. So we have two different intervals at which this graph is increasing. Remember, f prime increases means f is concave up. So we have from -10 to 3 and from 2 to 6. So let me just write a note off to the side, -10 to 3, and then we have 2 to 6. All right. Now let's go down and let's actually do some writing here. So once again, I'm going to use the same sentence frame as before. So f as, or sorry, in this case, f is blank on the interval blank because f prime blank. All right, so let's see. This is how I'd start. I'd start by just making a statement about f and justifying it with f prime. So f prime is, what did the question ask us? Concave up on the interval. So this is where we have to use our interval notation, -10, comma 3. We're just using x values here. And then 2, comma 6. And now we're just going to justify that because of what we saw f prime was doing. Because f prime was increasing on that interval. And I got this justification from my reference table up above that helped me relate those two things. So I would start with a sentence frame that started with my claim and then ended with my justification of what f prime is doing. Let me highlight this for you. And just make sure that I'm not using the word it. It is extremely vague and can be referring to anything. It could be referring to the graph, it could be referring to points, it could be referring to f, it could be referring to f prime. So I'm really specifically naming things like what f is doing, and I'm justifying it with what I see and notice from f prime. So those are some examples and some exemplary responses that you can refer to. And there's some sentence frames on the assignment itself. I'll upload this document with some more exemplars. Thank you for tuning in.